Let's revisit this problem about tipping from earlier in Unit 5. So if you recall this problem, they were investigating how writing a message on the bottom of a receipt at a restaurant might change the amount people tip. So specifically, they looked at using a "there's good weather tomorrow" message, a "bad weather" message, and no message. Originally, when we looked at this data set, we constructed a confidence interval to estimate the mean tip percentage if someone wrote "there's good weather tomorrow" at the bottom of the receipt. That's a useful thing to calculate, but what might be more helpful is to compare the good weather message with no message to determine if writing good weather causes people to tip more. So before we do a two-sample t-test, I want to tie in some of the material with experiments from Chapter 9. So identifying the factor and levels, response variable and control group, and then working on that experimental design. So I know it's been a bit since we've looked at Chapter 9, and I just want you to give this your best effort. To get you started with the diagram, they are using 60 patrons randomly assigned to either the good weather, bad weather, or no message group. So go ahead and pause the video and give this your best try. All right, so the first thing we were asked to identify is the factor. That's the thing we're manipulating or changing. That'll be the message on the receipt, and it has 3 levels: good weather, bad weather, and no message. Our response variable is going to be the tip percentage, and that's quantitative. And then for our diagram, so I noted that the simple random sample was not stated. And then we're going to start with 60 patrons, and they're going to be randomly assigned into 3 groups. So that means we'll have 20 patrons or customers in each group. And they're either going to get a good weather message, so one of the groups gets good weather, one group gets bad weather, and the other group gets no message. And then we'll compare the tip percentage between those 3 groups. Our control group here is going to be the no message group. Okay, so hopefully this is helping you to start tying together some of those ideas we've learned throughout the course and kind of how they all relate to each other. So with that in mind, I want to revisit this idea of statistical significance. So we talked about statistical significance. We talked about the difference being bigger than we would just expect from normal variation. So what we're going to do, we have the 3 box plots for the good weather, bad weather, and no message. And I want you to look at the means. Those are the X's for each of those groups, and we're going to compare them, and you're going to decide, mark down on your notes, whether you think there's a big gap or a statistically significant gap between the means or not statistically significant. So the first comparison, your alternate hypothesis 1, is good weather versus no message. So that'll be the box plot on the left and the one on the right. So look at those means and decide, are they statistically significant apart or not? And then the alternate hypothesis 2 is good weather versus bad weather. So that's the first and second box plots. And then the third one is bad weather versus no message. So that's the center box plot and the right one. All right, so hopefully you have a prediction for each of those about a statistically significant difference or not. And now I want you to do this 2-sample t-test. So at the 5% significance level, is there evidence that the good weather message results in a better tip than the no weather message? So the ordering for the subtraction here is going to be good weather minus no message. So go ahead and pause the video and give this a try. All right, so the first thing we're going to look at is that parameter statement, something about the mean of the good weather and the mean of the no message. So along the lines of, we're going to test the claim that the mean tip with a good weather message is more than the mean tip with no message on the receipt. The hypotheses, the null hypothesis is that the mean with the good weather minus the mean with no message is equal to 0. So we get about the same tip whether we write good weather or nothing. The alternative is that the mean with the good minus the mean with no message is greater than 0. So in other words, we're going to get a better tip if we write "there's good weather tomorrow" on the bottom of the receipt. All right, so before we can test that, we need to check our assumptions and conditions. We'll start with the good weather group. So when we looked at that experimental design, we said simple random sample not stated. So that's the same simple random sample that we're talking about here. So we'll put a star and write not stated. So that is concerning, but we've marked it and noted it, and we're going to move on with the test. Our sample size is n equals 20, so the central limit theorem doesn't apply here, but we do have the normal probability plot, and it does look pretty linear or like a straight line. So I'm going to call that normal. with a sample standard deviation of S is equal to 1.959. For the no message group, again, random sample not stated. This one, when I look at the normal probability plot, that drops off a little bit on the left side. Our sample size is in that moderate group though, about 20. So I'm okay to proceed with this. I'll mark normal. And then sample standard deviation is S is equal to 2.388. Right, we have two distinct or separate or independent groups. So that's what's giving us our two sample t-test. I got a test statistic of 5.06 and the p-value. So I want to talk about this because that probably was a little bit weird when you looked at that. There was probably a 5.86 something, 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 and then it said -6 at the end, or -0.6 maybe. So what that means is they're saying take 5.86 and multiply it by 10 to the -6. So in other words, what you have is 0.0000586. So practically zero for all intents and purposes. The p-value I got when I used the spreadsheet that I built is 3.53 times 10 to the -5. So similarly, very, very, very tiny, close to zero. Both of these are definitely less than the 5% significance level, so we do reject the null hypothesis. So our conclusion here is, with a p-value of 5.86 times 10 to the -5, at the 5% significance level, we do have sufficient evidence the mean tip percentage with a good weather message is greater than the mean tip percentage with no message. All right, so let's take a look actually at all of your predictions. So the one we just looked at was the good weather versus no message, and we found that we do reject the null hypothesis. That's the same thing as saying that your results, or the difference in the means, is statistically significant. So statistically significant goes with do reject the null hypothesis. All right, so the good weather versus bad weather. So this one had an even smaller p-value, 1.12 times 10 to the -7. So again, we do reject the null hypothesis, or the difference is statistically significant. And then our last one, the bad weather versus no message. Those look awfully close when I looked at the box plots, and indeed the p-value is 22%, so 0.22. So do not reject the null hypothesis is the same as the difference is not statistically significant.